Welcome to Druid Summit 2022, brought to you by Imply. My name is Mark Herrera. I'm a developer advocate with Imply. Today, we're going to talk a bit about Apache Druid and Apache Kafka and how they can work together, focusing on Kafka logs. We'll go over setting up a Kafka streaming ingestion job, talk about the location of Kafka logs within your deployment, and talk about a couple of common Kafka errors and what to do if you encounter them. So let's dive in. You probably already know that Druid is a high-performance, real-time analytics database to power analytics applications at any scale, for any number of users, and across streaming and batch data. And you probably already know that Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. Here's a quick glimpse of how many people are using Druid together with Kafka. Druid plus Kafka equals, I don't know, something like immediate intelligence? One more thing. If you're learning about Druid, want to take a deeper dive into a topic, earn a certificate for your LinkedIn profile, or just refresh your memory, please pay learn.imply.io a visit. Registration is free. There's even a logs course. We'll use some material from the logs course during this presentation. All right, let's dig in. Here's a snapshot of Druid and Kafka running and working together. You can see that Kafka scales horizontally, just like Druid, but mainly with one type of server. It's called a broker, and it broadcasts topics for consumption. Each topic is distributed as partitions on various brokers to fully handle the horizontal scalability of servers. Partitioning is the way Kafka horizontally scales the servicing of data. Druid can also consume Kafka in a distributed fashion. Just like with Kafka consumers, you can have up to one indexer running for each Kafka partition. It's also interesting to note that you can replicate the ingestion jobs for streaming. So, if one streaming service fails, the task can fail over to another indexer job. Generally speaking, one indexer can typically service multiple Kafka partitions, but that rule of thumb depends on the volume of the size of the tasks. You can see that parallelization can be easy. This all looks a bit theoretical, so let's take a look at things from a user's perspective. Once you've got Kafka running, the Druid console makes setting up an ingestion job easy. Here's what that looks like with the Wikipedia dataset. From the Load Data screen, click on the Apache Kafka button. From there, you'll be walked through the rest of the steps necessary to create a Kafka ingestion job. Here's what that looks like. Specify the bootstrap servers and the topic you want to read from. and whether you want to read from the beginning of stream or the end. It'll sample some of the messages in the topic and then parse the data into columns. The column names will be retrieved from the data source if the data source provides them. The first time column will be automatically selected as the primary time column, but you can specify a different one if you want. It automatically detects data types, but you can also create additional columns using transformations or remove columns from the schema. You can also use rollup here to aggregate the data as it's being ingested. Name your data source or table. Click Submit, and voila! This will initiate a long-running streaming ingestion process that you can monitor from within the web console. Congrats on completing a Kafka ingestion job. You can now query your data and start getting those real-time insights. But wait a minute, what all happened? Here's a blurb straight from the docs, but you know that logs were created and they contain lots and lots of great information about your ingestion job. Oh, and don't forget, there's a Druid logs course. Where are those logs? Well, there are a couple of ways to get to them. Here's another blurb straight from the docs. Here's the log directory at the root of the distribution that the docs mentioned. Since this is running a single node configuration, we can see the logs, like the broker and historical, from all the services here under the log directory. For a typical Kafka ingestion job, we may need to look at the coordinator overlord log and the middle manager log, and the task logs. But look how cool this is. You can easily find them in the web console. Under the ingestion view, you can click the magnifying glass to get the individual task logs. Okay. So now you've set up a Kafka ingestion and know where to find your logs. Let's talk about a couple of common Kafka ingestion errors. We picked these two because they seem to come up regularly. So here's a brief introduction to offset out of range exception and parse exception errors, how they come up, and how to deal with them. Offset out of range exception. It's going to look something like this, and it'll be in your task logs. This comes up when your Kafka ingestion is succeeding, but no data is being ingested. Data isn't being ingested because the stored offset is no longer available in the Kafka topic. This tends to happen when data is being consumed too slowly, or where there's been an outage of the ingestion process that lasts longer than the retention policy for the Kafka topic. So what to do about this? Some common sense preventative things can help. Increase Kafka topic retention or increase ingestion capacity. Think carefully about capacity planning to determine the scale you need and how many tasks you need. Or you can use the autoscaler. It'll automatically increase or decrease the number of tasks depending on the measured lag message processing. This will save on the use of resources. But if you end up seeing the offset out of range exception, there are a couple of things to do. The reset offset automatically property is set to false by default. When this property is set to false, if the supervisor is unable to find the offset it's looking for from the Kafka stream, the task will fail. You can then reset the supervisor to start reading from either the oldest or latest offset based on the setting for Use Earliest Offset property. This is definitely a strategic point. If Use Earliest Offset is set to true, Druid will try to pull the oldest offset available in the Kafka stream, and this could lead to duplicate data for partitions where it has not fallen behind. If this is set to false, there is a chance some data might be lost. Lost data can be recovered by backfilling, provided that data is stored somewhere else. But you get the point. Parse exception. You'll see this when a row can't be parsed. This can happen when there are issues with your data. Something like an incorrectly formatted timestamp. So, what to do about this? Maybe some prevention. Keep an eye on your unparsable events. But if you end up seeing the parse exception, there are a couple of things to do. Check the health of your supervisor. If your supervisor is unhealthy, consider suspending and resuming it, or resetting it. Also, look at max parse exceptions. It's a property within your tuning config. This property sets the maximum number of parse exceptions that can occur before the task halts ingestion and fails. But be aware that if you allow for parse exceptions, you may potentially lose messages. And that is about it for this presentation. Thanks to my colleagues on the Developer Relations team for helping me prepare this talk, and a very special thank you to the Customer Success team. Speaking with them, reading through their knowledge base, and reading through many of their help desk tickets made this presentation almost write itself. If you have any questions about what you've seen today, register on the community's channels and raise a question. Say hi to us, we'll say hi to you. Visit learn.imply.io for Druid-related courses, including the logs course. And please say thank you to the developers behind Apache Druid with a star on the Apache Druid GitHub repo. See you next year.